All right. So last time we were talking about simple interest. Any question on those? No? All right. So today we're going to go ahead and talk a little bit about compound interest. The difference between simple interest and compound interest is the following. In a compound interest, you get paid interest on top of the interest. What is, if you deposit a certain amount of money in a bank, the bank pays you, let's say, 5% compounded, say, annually. That means at the end of every year, whatever interest you've collected, it will be added to your account. So next year, your principal money starts from whatever the first year ended. Okay? So the first year, let's say you had $100, then 1 year later, then now you have 105. The second year, you get interest paid on the $105. On the simple interest, you'll always get interest paid on the principal money you started with, $100, regardless for how long you have it. Okay, every year it's $100. But with the compounded interest, they add the interest to your account, and then they start from there, accumulating a new period, a new year. At the end of that year, they start with that amount. So let's go ahead and take a look at, say for instance, you have $100. Let's talk about the $100. You deposited $100 in a bank account that pays 5% compounded yearly. Let's start with yearly compound. Okay? So that means at the end of year number one, you will get your money in the bank. You have $100, what you started with, plus the interest. Yes? The accumulated amount in 1 year or at the end of year one is 100 times 1 plus, remember, last time we said your amount of money will be your principal times 1 plus RT, correct? So that was the future amount that you will have if you deposit money based on a simple interest, yeah? Okay. So after 1 year, your amount of money that you have in the bank is 100 plus 1 plus R, which is 0.05, because we're talking about 5%, yes? But T is how much? T is 1, because it's only for 1 year, yeah? So that is equal to 100 times 1.05. So far, so good? Okay. Now, let's say year number one ended. Now, this is how much money you have at the beginning of year number two. Okay. At the end of year two, end of year two, you have whatever you started with, yeah, and that's going to be your principal, 100 is 1.05 times 1 plus RT again, yeah? So 1 plus 0.05. Now from the end of year number one to the end of year number two, you only have 1 year. So T equal 1. So let's go ahead and ignore that. Yeah? So now when I multiply these, I get 100 times 1.05 squared. Yeah? Any questions so far? So this is at the end of year number 2. Let's go to the end of year number 3. The amount of money you have at, say, year 3 is whatever you started with in year 2, at the end of year 2, which is 100 times 1.05 to the power 2 times 1 plus RT, which is 1 plus 0.05. Again, T from the end of year 2 to the end of year 3 is just 1 year. Yeah. So 0.5 times 1 is just 0.5. If I multiply these, we end up with 100 times 1.05, because this is 1.05, times 1.05 squared, that will be cubed. Okay? Now notice, year 1, 1.05 to the power 1. For year 2, 1.05 to the power 2. For year 3, 1.05 to power 3. Yeah? So what happened after 10 years? What would it be after 10 years? So A after 10 years is 100, 1.05 to the power. Yeah? What happened after T years? A after T years. Again, 100, 1.05 to the power. So that is based on the fact that we're going, how far? We're going 1 year at a time. Yeah? What happened when we go, say, monthly? Banks don't wait 1 year to give you the interest. They probably give you the interest every month or every week or what have you. Yes? So let's go ahead and redo this a little bit and see what happens. So now instead of talking about years, let's talk about say month. Okay, let's take a look at this equation a little bit. Every period, or in this case, every month, the bank is supposed to put money in your account. That is your interest. Yeah? If you get paid 5% compounded monthly, that's 5% per year. Every year, 5%. But every month, let's make that 6%. Let's make that 6%, just to make the visualization of the calculation a little bit better. If you have 6% compounded monthly, but it is 6% per year, that means one thing. Every month, you're getting an interest rate, R, equal whatever this is, divided by how many months are there in a year. Okay? So that means every month you're getting 0.5%. Okay? We're clear on that? Okay. Now let's go ahead and do the same thing we just did. But instead of counting by years, let's count by month. Okay? Because the bank is going to put the money for you every month. Yeah? At the end of month 1, you have the $100 you started with, yes, so 1 plus the interest rate for that month, which is 0.5%, which is 0.005, and that's how much money you have at the end of month one. That would be 100 times 1.005. At the end of month two, what do we have? Now, at the beginning of month two, this is how much you have. Okay? Then you're going to get the interest on top of that. So that's going to give me 100 times 1.005 times 1 plus 0.005. So 1.005, 100, 1.005 square. Okay? Is it going to be any different than what we just did with the year? No. But instead, at the beginning, because it was compounded yearly, we were counting how many years. And that's what we put there, right? And in here, we have the interest you were getting every year. Now it is what? On top over here is how many months, yeah? And in here, we put in what? The interest you're getting per month. Yes? So now, a general formula says the future value is equal to the initial value, PV, times 1 plus, let me just go ahead and put I, yeah, to the power and T. What is N? Okay, let's go ahead and explain all of these terms. Future value or accumulated value. We could have those switch around. Sometimes some books use accumulated value, some books use future value, but they are the same. So A or FV is future value or accumulated amount. Okay? I is interest rate for compounded period. What does that mean? If the compounded period is monthly, then I would be whatever R is, yeah, divided by 12. If the compounded period is weekly, then I would be whatever the interest rate is divided by 52, and so on. Yes? So always we want to divide by how many periods are there in 1 year of the compounded period. Yeah. And then what else we have? Well, we say N. N is, again, number of compounded period per year. So N would be, if we're doing compounded monthly, N will be 12. If we're doing compounded weekly, N would be 52. Daily, N would be 365, and so on. Yeah. Again, T is number of years. Yeah. So now we specified N to be the number of compounded period per year. We can rewrite this formula a little bit different. And in here, instead of saying I, we would say R over N. Yeah? Where R in this case is interest rate per year. R over N, or R is the interest rate per year. Let's do an example on that. Okay, it says, if $7,000 is deposited in a saving account that pays 4% interest compounded annually, how much money in the account after 9 years? So now we have the following. We have $7,000 in a saving account at 4% compounded yearly. Compounded yearly means one time every year. So at the end of the year, you get your interest added to your account. Yeah. For 9 years. Okay. For 9 years. Question is, how much money you have after 9 years? Okay, I'm going to use this for book maybe have I to the power n, but this is going to work for everything regardless. Yeah. If we understand those terms, what they are. Yeah. First of all, we need to know what PV is, right? What's the present value? Or the principal? The 7,000, the amount you started. Yes? So PV equal 7,000. So I'm going to go ahead and identify every factor or every term in that equation and then just substitute and work it out. Yeah. What is R given at? In a decimal form is 0.04, because that's what it says, 4%, yes? Now, what is N equal to in this case? N is equal 1. Why? Because it says compounded how much? How far? How often? Yearly. Yes? That means one time every year. Yeah? So N equal 1. And how much? What is T? T is the 9 years. Now I got all of these terms in here. All I have to do is just substitute it into the equation and figure out how much money we will end up at the end of 9 years. So that's going to be 7. So the accumulated amount or the future amount, let's see what term your book uses. No, it uses a future value as well. Yeah, so let's go ahead and use a future value. So future value is 7,000 times 1 plus 0.04. Dividing by 1, really, you can just leave it 0.04, right? And then again, on top we have, I'm just going to illustrate this so you can see all of it. So 1 times, and t here is 9, so 1 times 9. So that is equal to the 7,000, 1 plus 0.04, the power 9. And the answer to that is after 9 years. Does anybody have an answer? It says over here $7,571.20. Actually, no, $9,963 and 18 cents. You always went around to 2 decimal places. Yep. You always went around to 2 decimal places. And let me go ahead and shut this phone off. All right. Any questions? Let's do another one. No. Okay. It says over here, a $16,000 saving account grows to $50,000 in 18 years. Okay? So we started with $18,000. Is that what it says? I'm sorry, 16,000. So $16,000 grew to 50,000. Man, they were giving that account a lot of vitamins in 18 years. And it says, what is the interest rate? Assuming compounded annually. Okay? So let's go ahead and do that. So we have find the interest rate assuming compounded annually. Yeah? Well, we just learned one formula. And that formula we learned is future value equal present value times 1 plus r over n to the power n t. Okay? And we need to know what r is. We need to know what r is. To know what r is, we need to know what the future value is, the present value is, we need to know what n is, we need to know what t is. Do I know all of this? Let's see. In this case, what is your future value? Future value is 50,000. This is where the money grew to that amount. What is the present value? 16,000. Yeah. Well, we don't know what R is because this is the one we're looking for, right? So N in this case equal how much? 1, because we're talking about compounded annually. Yeah. And T is how long was it? 18 years. So now we do know all of this. All we have to do is substitute it in there, and from there work it out. Okay? So let's see if we can work it out. So we have future value 50,000 equal present value, which is 16,000 times 1 plus R is what I'm looking for. Yes? Since N is 1, let's ignore that. Since N is 1, let's ignore that. To the power NT, again, N is 1, let's ignore that. T is equal to 18. How do I solve this? Well, we know we're looking at the term inside the parentheses that has exponent, right? First, I'm going to isolate this term by dividing both sides of the equation by 16,000. Yeah. So 50,000 divided by 16,000 equal 1 plus R to the power 18. Yeah. So far, so good. Any questions? So these are basically, I can take 3 zeros out. That's 50 over 16. If I divide both of these by 2, I end up with 25 over 8. So 25 over 8 equal 1 plus R to the power 18. What do I do to get rid of that exponent? Square root of it was just 2. 18th root, yes, or to the power 1 over 18, yeah? So I can raise this to the power 1 over 18, yeah? And I can raise this part to the power 1 over 18. Now these two cancel out because they give me 1, yeah? So now what do we have? We have 25 over 8 to the power 1 over 18 equal 1 plus R, but I just want R, right? So I'm going to subtract 1. So that is equal, so R equal 25 over 8 to the power 1 over 18 minus 1. Okay? And then for this problem, we should end up with 0.06535. But we want the percentage, yeah? So what is, shall I convert this to a percent? What do you get? R equal 6.535%. Okay? All right. Okay, it says, Ali Bank advertise a market account and it pays interest rate of 0.85%. It says find the value of the amount of the account if $10,000 invested for 1 year and the interest is compounded according to the period given below. So in this case, we're gonna take $10,000, right, at 0.85%, and we're gonna evaluate it for 1 year at different compounded period. See what happened to the account as the compounded period changes. Okay, let's start with that. So we're starting with investment of $10,000, 0.85% for, let me see the first compounded period. The first compounded period says if we're compounding annually. That's, so this is for 1 year. A, compounded annually. Compounded annually. For that, we're going to use a formula. All the time, in this case, we're going to use the future value formula equal the present value 1 plus R over N power NT. Okay, let's see. So we have future value here is 10,000. 1 plus R is 0.0085. Yeah. N is 1 because first one is we're doing compounded annually. And the exponent here is going to be 1 because it's just 1 year. Yeah. And that should give me $10,085. So after 1 year, we have $10,085 in the account. Okay. Now let's take a look at RB. It says the compounding semi-annually. Yeah. We're going to use the same formula, right? Okay, so let's see. 10,000 to the future value, 10,000 times 1 plus 0.0085 divided by, what is N in this case? 2, right? Semi-annually means how many times a year? Twice. So this is 2 to the power of 2 times 1. N is 2, number of years is 1, the power 2 times 1. Yes? And the answer for that one is $10,085 and 18 cents. So notice when we did the compounding, instead of once a year, we did it twice a year. We got how much more? 18 cents more. Yeah. And remember, the interest rate is too small, right? If that was a bigger interest rate, you have a bigger amount difference. That's why on my math lab, when you're doing the problems, you gotta be careful when you round, right? You may round it differently, and then you end up with a different category for compounding, because the amount is not too much different in these cases. Yeah. Let's do quarterly. What does, when we compound it quarterly, what does n equal to? 4. We're doing 4 times every year, right? So this formula is going to be the same. 10,000 times 1 plus 0.0085 divided now by 4, because we're doing quarterly, yes? To the power 4 times 1. Again, and it's 4 for 1 year. And in this case, your answer would be 1085.27. And 085.27. Again, we expanded we got more, what do you call that? Compounded more periods, right? The money was even more. Done. And when we do monthly, so let's do a monthly. What is n in this case? 12. So it's going to be same thing. 10,000, 1 plus 0.0085 divided by 12 times to the power 12 times 1. Yep. And in this case, we should end up with 1085 and 085, 33. So notice, now at the first jump was 18 cents, right? The second jump was a little bit more, by just basically 9 cents, right? Now, even though here we did it 12 times, the jump is only 6 cents, right? Now, when we do daily, how much do you think it's gonna be? Let's go ahead and do that. So it'll be 10,000 times 1 plus 0.0085. What is n now? $365. We'll go with 365. Again, remember I said last time, we go with 365 for days per year, unless they say otherwise. Yeah? To the power 365 times 1. And that should give me 10085.36. Now notice now the amount starts to get a little bit, the difference is a little bit low. So now, even though we went up to 365, but it was only difference of how much? 3 cents. Okay. We clear on that? But it's still you have to pay attention to your calculation, especially when you're doing problems on my math lab, because any tiny difference could make a difference between compounding monthly and compounded daily, especially if the interest rate is too small. Yeah? And when they do that on my math lab, they be very careful on that. Now I want you to use your calculator for a few things. Yes? Okay. I'm not going to take this amount. I'm just going to take $1. We're gonna take $1. Yeah? And we're gonna do the same thing right now. How many hours are in a year? How much? 8,760. So we have 8,760 hours. Yes? You sure? All right. We'll go with that. Okay. Let's say you have $1 and you're doing compounded hourly for 1 year. Okay? And let's say at 1%. So we're gonna say $1 times maybe 1 plus, right? 1 over 8,760 to the power 8,760, right? I don't have a calculator with me. Why don't you guys do that on your calculator? Give me an answer. How much is it? 2 point something, 2.7, 2.71. So that's approximately 2.71. Yeah? I'm greedy. I want more. Let's go for, instead of compounded hourly, yeah? How many minutes in a year? Multiply that by 60. Go ahead. 500? 25,600. Okay, let's do that. So let's go 525600. Is that a second or a minute? Yeah? Okay, multiply that. Let's see. Anybody got an answer? Like 2.718 something? Yes? Does that remind you of something? Why don't you look up the value of E? So when we look at the value of E, it ends up to be 2.718 something, right? That is basically if you put your money in a bank at continuous compounding, another way, infinitely many periods per year, what happens? This whole terms over here becomes close to E, yeah, to the power I. This term becomes E to the power I. So when we have continuous compounding, yeah, continuous compounding, then a future value is EV E to the RT. Now let's take a look at this term over here. 1 plus R over N to the power N. We said N is infinite, right? We said N is infinite. And R over N is, let's say N is equal to some M times R. Yeah? M is equal some number N is equal some number M times R. And then I can rewrite this as 1 plus R over MR, right? To the power MRT. Yes? What happened with those R? They cancel out. So it's going to be 1 plus 1 over R M to the power M. And let's go ahead and just make that RT on top. We just did this. We were practicing over here, right? We were practicing over here. The bigger the M is, the closer this number is to the value E. Okay? So actually, if M is infinity, then this becomes exactly E. So that's equal to E to the RT. So this whole thing becomes E to the RT times the present value, whatever it is, and that's where your continuous compounding come from. Okay? And that's where E comes from. So you know what it is. Okay? Any question? No? All right, that's it for today. I'll see you guys back here on Monday. Have a nice weekend.